But let's quickly cover through what is ratio and proportions. So ratio is basically, it's a fraction. In the simplest term, what is a ratio? It's a fraction. So if I say that I am mixing water and milk in the ratio 1:2, it means that for every one part of water, there are 2 parts of milk. So basically, what is the ratio of water in the whole mixture that is formed? That would be 1 part out of 1 plus 2, that is 1/3. And how much would be milk then? That would be the remaining 2/3. So what is ratio? It's essentially a fraction. It is saying that 1/2 of the milk portion is the water portion. So when I say, okay, A is to B is 1:2, I am basically saying you can write, instead of A is to B is 1:2, I can write this as A by B is 1/2. Or I can say that let it be that B is equal to 2 times A. It's the same thing. So whatever is a ratio, it is nothing other than a fraction. Whenever you are treating ratios, treat them as fractions. That's all. But the thing with the ratio is like in a fraction, there is only the top and bottom. There are only 2 things that are there in a normal ratio, in a fraction. You don't have like 3-way fraction, etc. But you can have 3 parts ratio, 4 parts ratio, 5 parts ratio, any n parts ratio. So how do you read something like that? See, when you read a ratio, you will say that, okay, for 1 part of A, there are 2 parts of B. Similarly, if I say that if the ratio is 1:2:3, how do you say this? By the way, this is called as a antecedent. This part, which is in the numerator, instead of calling it numerator for ratio, instead of calling it numerator, you call it antecedent, and you call it consequent, which is the bottom part. But doesn't matter. It is like remembering this is not needed at all, because it will not be asked in CAT. You can call it numerator, denominator also. It doesn't matter at all. But just for your sake, I'm telling you the term. But the point that I want you to know is that just a ratio, treat it like a fraction. But the only additional thing about a ratio is that it can have 2 parts, it can have 3 parts, it can have 4 parts, it can have 5 parts, n number of parts. So essentially, how do you read a ratio like that? So you will say that suppose this is the ratio of milk to water to, like, say, kerosene, whatever you're mixing. So what does this mean? That you take 1 part of milk. For every 1 part of milk, you take 2 parts of water. For every 2 parts of water, you take 3 parts of kerosene. So you can read this as 2 fractions. That milk by water is 1/2. Similarly, water by kerosene is how much? This is 2/3. And milk by kerosene will be how much? It will be 1/3. So you can convert this into fraction. But one ratio of 2 parts gives you 1 fraction here. One ratio of 3 parts will give you like 3 fractions. But nothing much as such. You can think of ratio as fraction itself, because most of the time the ratio that will come is a 2-part ratio. Even when they are asking you what is the ratio, you are just basically saying that if I were to make a fraction out of part A by part B, what would that fraction be? That's all you have to say. So what would be m:/n? If you are asked in the question, what is m:/n? You have to just basically say the ratio m/n. What fraction is that? M/n in its lowest form, what is that fraction? That is all you have to do. Okay. This is essentially the very basics of ratio. Now coming to the properties of ratio, there are multiple properties. I will tell you what they are, but many of them are pretty simple and self-evident. Consider a fraction, okay, m/n. If I multiply m by a and n by a, do I change the fraction? No. The same is the case with a ratio also. If I multiply the numerator and denominator, the fraction doesn't change. Same way, if I multiply the consequent and the antecedent with the same number, it does not change the fraction. It does not change the ratio at all. Instead of saying ratio, I'm saying fraction because it is a fraction. That's it. Okay. So if I multiply and divide by the same number, it does not change the ratio. Now, if I add and subtract, what does it affect? How does it affect the ratio as such? This is true even if I divide. Okay. By the way, if I say that m by a divided by n by a, still the ratio remains constant. It does not change the ratio at all. It will be equal. M by n will be equal to am by an will be equal to m by a divided by n by a. It does not change it. So basically, if you multiply and divide the antecedent and consequent by any constant, the other than that, the fraction or the ratio does not change. Now, how does it affect if you add or subtract? Consider the ratio if you have the ratio half. If I add 3 to the numerator and 3 to the denominator, how does it change this ratio? So this will become 1 plus 3 and this will become 2 plus 3. Sorry about this. So this will become 4 by 5. Half is around 50%. 4 by 5 is 80%. So has our ratio increased or decreased? Our ratio has increased, which means that if I add and subtract, so if I add numerator and denominator in a ratio, and if the ratio is a proper fraction, meaning the denominator is greater than the numerator, the ratio increases in value, the fraction increases in value, okay? If I subtract, if it's a proper fraction, suppose if it is 3 by 4, and I subtract 1 from numerator and denominator, what do I get? I get 2 by 3. 3 by 4 is 75%, 2 by 3 66.67%. So is my fraction or ratio decreasing or increasing? If I subtract and it was a proper ratio, it will decrease. So if I add, if I have a proper ratio where denominator is greater than the numerator, that is the consequent is greater than the denominator is greater than the numerator, if I add a value, what will happen? Its value will go up. If I subtract a value, its value will go down. That's all you have to remember, that when it is a proper fraction, when you add a value to numerator and denominator, the value goes up. If it is an improper fraction, the ulta thing happens. What is the exact opposite will happen? So if you have 4 by 3, okay? If you have 4 by 3, if I add to numerator and denominator, I get 5 by 4. 4 by 3 is 1.333. 5 by 4 is how much? 1.25. So this is actually going down. So when you have an improper fraction and you add to the numerator and denominator, adding, the value goes down. When it is an improper fraction and I say deduct, okay, remove. 4 by 3, suppose if I remove 1, okay, this will become 3 by 2. 3 by 2 is 1.5, this is 1.33. It will actually go up. So you can see it in this way, okay. If you can see a number line, in a number line, you can say that this is the number line and this is say 1, okay, this is 0. If your fraction is more than 1, okay, if your fraction is more than 1, adding will reduce the fraction. Subtracting values will increase the fraction. But if your fraction is less than 1, that is numerator is less than denominator, adding will increase the value. Subtracting will decrease the value. Why should you know this? Why is it important? Sometimes it is important in figuring out what the ranges can be. It is sometimes important in figuring out what the values, potential values can be. If I am telling you that the ratio say goes down, if I remove some equal parts of x and y and the ratio goes down or ratio goes up, it can tell you basically whether it was a proper fraction or an improper fraction. So by that you can also figure out, okay, what can be the potential answers. You can eliminate options by using that. So that's why this is important to know that when a particular ratio is less than 1, a is less than b, a is to b, where a is less than b, if I add x to numerator and denominator, a plus x divided by b plus x, the ratio will increase. On the other hand, if I do a minus x and b minus x, the ratio will decrease. If a is greater than b, that is the numerator is greater than denominator, a plus x divided by b plus x, the value will go down. If I have a minus x divided by b minus x, the value will go up. So always remember this side of 1, adding increases, subtracting decreases, which is what you expect. That side of 1, adding decreases, subtracting increases, which is like the inverse of what you expect. Now we come to the basic ideas of invertendo, dividendo, all of these things. Where do you use this? If you have never heard of this, don't worry, it is not super important, but you would have used it without knowing all of these names. Like without knowing alternando, dividendo and componendo, dividendo, etc., you would have definitely used it. So where is this used and what is it essentially? So invertendo is simple. Consider A by B is say C by D. So what does invertendo mean? It means that you can invert this ratio. So if A by B is equal to C by D, you can say that B by A is equal to D by C. This comes from basic fractions, right? You invert the fraction, invert of one side of the fraction, you invert the other side of the fraction. Simple. There is nothing really new to it. But if I say invertendo, half of you will be like, what is that? I've never heard of it. But it is a simple basic, you are inverting the fraction. Now what is alternando? Alternando also sounds like such a fancy concept. It is nothing. You bring C over here in the denominator, you bring B over there to the numerator. So you can say that A by C is equal to B by D. How do you get this? You cross multiply, you can say that AD is equal to BC. So if you know that AD is equal to BC, you can change the what is there in the numerator and the denominator. You can interchange what is there in the numerator and denominator. So if A by B is C by D, then A by C is equal to B by D. Instead of taking B in the denominator, I take C in the denominator, I get what is called as alternando. But essentially it's just swapping the denominator of one with the numerator of the other sides. That's all it is. Componendo. Componendo is slightly different. Okay, sometimes some people will understand it quickly, sometimes some people will not get it. So I'll tell you in its basic form what is alternando. If you are say A by B is equal to C by D, add 1 to both sides. 1 plus A by B is C plus D by 1. I've added 1 to both sides. Now take this, cross multiply, take it in the numerator. So what can you say? A plus B by B is C plus D by D. This is just componendo. That's it. There's nothing really to it. This is componendo. Okay. Similarly, what is dividendo? Instead of adding 1, subtract 1. That's it. So you will say A by B minus 1 is C by D minus 1. Take A by B minus, so you will say this is A minus B by B is C minus D by D. That's it. This is dividendo. This is componendo. This is dividendo. Where is this useful? Where does it come in? Where does it help you? This comes in very useful in whenever ratios or fractions are given of algebraic quantities. So when you have algebraic identities like this, you can use this to cancel off some common terms. So if you have like say x square in numerator and denominator, you can use this to like cancel off x square in one of the places. So if I cancel off in one of the places, then I'll at least simplify the equation. That's where componendo dividendo comes in helpful. Now I have this equation, say this is equation 1, this is equation 2. If I divide equation 1 with equation 2, what do I get? I get my componendo dividendo. What is componendo dividendo? A plus B divided by A minus B. This is equal to C plus D divided by C minus D. That's all that is there. What is componendo? What is dividendo? This is basically adding 1. This is subtracting 1. If I divide this equation by this equation, I get componendo dividendo. Remember these basic ratio and proportion or fractions like interchangeability and these operations, because they can help you quite a bit when you are dealing with algebraic identities. Why is this in algebraic identities? See, for example, if you have something like x square minus 4x and x square plus 5x, okay, you can say this is say m by n, okay. One thing that you can do is you can cross multiply and you can do something with that, or you can do a basic componendo dividendo, or you can do just part of it. You can just do dividendo to reduce one of the values. You can reduce one x square from at least numerator or denominator. So if I do a dividendo, x square will cancel. I'll get minus 9x divided by x square plus 5x, and I'll get this is m minus n by n. So by doing that, what am I doing? At least in numerator, I am removing the x square term. So from that, I am reducing the complexity of the algebraic equation. That is basically where most of these ratio and proportion rules come in very handy. Let's go to the next concept. I'll briefly go through the concept that is of like, this is basically if you have proportion where multiple terms are given. This can come in when you have a like if you have 3-4 ratios given, sometimes directly a result might be asked, okay? So they might give you that this, so give the value of like some particular combination of these terms. The thing that you have to remember is that as long as the ratio is equal, right, like this, you can just say that everything, any combination of those ratios will be equal to the same ratio. How is that? See, basically say that A by B is equal to say C by D is equal to say E by F. Say this is equal to K. So you can say that A is BK, C is DK, E is F times K. Okay? So I will say that if I am taking the sum of A plus B plus C plus E, A, C, E. If I am taking the sum of A, C, E, what do I get? I will say this is A plus C plus E. If I take this divided by B plus, not like B plus D plus F. I can replace ACE by A, I can replace by BK, C I can replace by DK, E I can replace by FK. So I'll get that I can take K in common and I'll get this is B plus D plus E divided by B plus D plus E. So this cancels off and I get this is also equal to K. This is also equal to the same ratio as such. This same ratio I can see if I add up all the numerators and add up all the denominators, I get the same ratio. If I multiply the ratio, if I multiply this by say P, this by Q, this by R, and then take the sum, still the same ratio, it will still be equal to K. Because what will happen is that each time whenever I'm taking that kind of a ratio, it will just cancel each other off. Like the numerator and denominator will cancel each other off and will be left with K each single time. So whenever any such configuration is given where you have the sum of numerators divided by sum of denominators and you are asked what is the value of this, it will generally be the ratio itself. Suppose I have it raised to n, okay? Here you have PA raised to n, Q raised to C raised to n and so on. See, if I have A by B is equal to C by D is equal to E by F. If I square it, it will be equal still. So A square by B square will be equal to C square by D square will be equal to E square by H square. A raised to n by B raised to n, C raised to n by D raised to n, E raised to n by F raised to n. It will, all of them will be equal and they will be together equal to like K square, or if it is n, it will be K raised to n. That's all that you will get. So if you have a equation like this, you have say instead of 2 you have n over here. So what will you say? A raised to n by B raised to n will be equal to C raised to n by D raised to n and so on till you have this is equal to K raised to n. I will multiply this by some constant P, P, Q, Q and again I take the sum. So again I will get this entire sum will be equal to K raised to n. I take K raised to n raised to 1 by n, I get the same ratio K. So again all of these like this A, if A is equal, A by B is equal to C by D is equal to E by F, it is equal to the sum of the numerators divided by the sum of the denominators. It is equal to a weighted sum of the numerators divided by a weighted sum of the denominators. It is equal to a weighted sum of each individual parts raised to n divided by the weighted sum of each denominator raised to n, the whole raised to 1 by n. Because if I just take this without this part, 1 by n, this will be basically raised to this part. This part over here is K raised to n. So K raised to n raised to 1 by n, I am taking the n square root, I get K again, which is equal to my original ratio. Okay. The last part I'll quickly go through and then we will go to the ratio questions as such. I won't spend too much this unnecessarily. See, these are terms that I'll quickly cover, but I'll give you a basic idea that this has never been asked in CAT. It has been asked in ZAT, but this concept has never been asked in CAT. But I'll still tell you what each term refers. Duplicate ratio is basically if A by B is my ratio, then the duplicate ratio of A by B is A square by B square. What is triplicate? Triplicate ratio, you don't triplicate ratio, you don't multiply by 3, you cube. So this triplicate ratio will be A cube by B cube. What is subduplicate ratio? Think of it. What would subduplicate ratio be? It means by raising the ratio to half. So this would be root of A by root of B. This is the subduplicate ratio. Subtriplicate ratio, that is cube root of A divided by cube root of B. To be honest, this is never asked. In CAT at least, I don't remember any time, even a single time any of these has been asked. But duplicate ratio has been asked in that. So to that end, I am covering it. But this part, this concept, just remember what duplicate ratio is, triplicate ratio is. Sometimes people might think that duplicate ratio would be doubling the ratio. But you know that doubling the numerator and denominator makes no change to the ratio. So always remember, duplicating or triplicating will have to do with something raised to, like raising it to a power rather than multiplying it with a constant. So this is the idea of concept of duplicate and triplicate ratio. We have covered the concepts of ratio and proportion.